All right, let's dive right in. Today, we're talking about one of the most critical and seriously in demand roles in the entire tech world, the data engineer. So let's get into it. Okay, first things first, let's tackle a huge misconception I hear all the time. You might have heard people joke that data engineers are just, plumbers for data. But is that really the whole story?
Well, not quite. I mean, sure, they connect the pipes, but that's like saying an architect is just a bricklayer. No way. Data engineers are the master architects, the builders of these massive data superhighways that literally power modern business.
So here's what we're going to cover. First, what is a data engineer, really? Then we'll look at the modern data pipeline, their actual blueprint. After that, we'll lay out a roadmap for you to build the right skills. We'll check out their essential toolkit. And finally, and this is crucial, we'll talk about how you can prove your worth and land that job. So let's get right to the point. Data engineers, they are the absolute backbone of any company that wants to be data-driven, period. Think about it like this. They handle the entire journey of data, from the moment it's created all the way into the hands of the analysts and data scientists who turn it into actual business insights. They own that whole process. Okay, so that's the what. But what about the how? How do they actually pull all this off? Well, to really get it, you've got to understand their blueprint. And that blueprint is the modern data pipeline. Whoa, okay, I know this looks a little complex at first glance, but don't worry, it's really just a map of the data's journey. See over on the left? That's where it all starts, in the source systems. Then it flows through a bunch of key stages until, bam, it's ready for analysis. Let's walk through it. First up, you have to get the data out of wherever it lives, from all the different apps, databases, APIs, all that stuff. This very first step is called replication or ingestion. Right away, there's a huge architectural decision to make. Do you go with ETL or ELT? The old way was ETL, extract, transform, then load. But the modern cloud-friendly approach is ELT. You extract the raw data, load it straight into the warehouse, and then transform it using the warehouse's own power. It's a total game changer. So, where does all this raw data go? It usually lands in what's called a data lake. And you can literally think of it like that, a giant, vast lake of data in its original native format, just sitting there waiting to be used. But here's the thing, not all data lakes are created equal. You've got a choice to make. You can go with a file-based lake, which is super cheap and amazing for messy, unstructured data, or you could opt for a relational lake, which is going to give you way better, faster query performance. It's all about trade-offs. Okay, so you've got this lake of raw data. Now what? Well, now comes the magic, data transformation. This is where you clean it, you structure it, you model it. You take that messy raw stuff and turn it into something clean and reliable. And this is where awesome tools like dbt and Spark really shine. And the final destination for all this beautifully transformed data? The data warehouse. If the data lake is a giant raw reservoir, the data warehouse is like a pristine, organized library. Everything is structured, integrated, and perfectly designed for super fast analytics. All right, so maybe looking at that blueprint got you a little inspired. You're thinking, okay, I get it, this is cool, but how do you actually become a data engineer? What are the steps? Well, let's lay out an actual roadmap you can follow. We can break this whole journey down into 5 big stages. Step 1, programming foundations. You gotta know your code. Step 2, database and modeling mastery. This is all about how you store and structure data. Step 3, big data processing, because you're going to be dealing with massive data sets. 4, orchestration and the cloud, which is how you automate it all. And finally, step 5, DevOps and infrastructure. This is where you learn to manage the whole system like a pro. Look, everything, and I mean everything, starts here. You absolutely have to have a rock-solid foundation. We're talking Python for scripting, SQL for talking to databases, and not just the basics, you need the advanced stuff. And then you need essentials like the Linux command line and Git. These are completely non-negotiable. Okay, so once you start building those skills, you're going to need the right tools for the job. And believe me, the landscape of tools out there is huge. But don't get overwhelmed. There are a few key technologies that form the core of pretty much every modern data stack. So here's a look at some of the heavy hitters. You've got tools like Airbyte, dbt, Spark, Snowflake, Airflow, a bunch of them. But the really cool thing to notice is how each of these tools maps directly back to a stage in that pipeline we talked about. You've got Airbyte for ingestion, dbt for transformation, Airflow for orchestration, See how it all fits together? All right, knowing the skills and the tools is awesome. It's a huge step, but you have to prove you can actually use them. And that, my friends, is where your portfolio comes in. This is your proof.
And listen, a really strong portfolio is so much more than just a folder full of code on GitHub. It has to tell a story. It should show not just what you built, but why you built it. What problem were you trying to solve? What was your thought process? That's what people want to see.
And don't just take my word for it. This is exactly what hiring managers are looking for. They want to see that you can think on a higher level, that you can think like an architect. How does the data flow? What are the trade-offs? It's not just about listing the tools you've used. And one last thing on this, and please listen, document your work. You could have the most amazing, brilliant project in the world, but if the documentation is terrible, it can totally fall flat. A clear README is a sign of a real pro.
Okay, let's wrap up by tackling the elephant in the room, right? AI. It's getting scary good at writing code. So, what does that mean for the future of the data engineer? Is this job even going to exist in a few years?
The answer is the job isn't going away, it's evolving. Look, AI is going to become an incredible tool. It'll automate all the tedious boilerplate stuff, and that's a good thing. It's going to free up engineers to focus on what really matters, the high-level architecture, the system design, the creative problem solving. Those conceptual skills are becoming king, and that's what will define the great data engineers of the future.